Hey guys, welcome back to my YouTube channel. Now, in this video here, I want to walk you through exam possible questions or past questions in what atomic structure, what and bonding. These are regular questions JAMB ask every single year, and some of these questions I'm going to treat in this video. You're going to see them in the exam. So this is just like a revision class where I'm going to explain some set questions. In the course of me explaining, I'm going to explain some things that will be of help to you in that topic. So you really want to stick to the end of this video. Now, if there's any topic in chemistry you want to create for you or do exam possible question on, kindly leave it at the comment section. Now, I already have a list of exam possible questions topic I want to create on. But now, the one that comes most, that is what I'm going to pick next. You get. So if there's any video, there's any topic you want to create exam possible question on, you get. Then leave at the word comment section. Please kindly share this video to your friends who are also writing chemistry in the upcoming JAMB, so that they too can also benefit from this video. Okay. Now let's get started. Let's start. So, which group of the periodic table does an element with atomic number 16 belongs to? So now, if you ever give an element without the periodic table and they ask you what is the period, what is group, and what is block, you get. So yeah, they are talking about the group, right? So which group does an element with atomic number 16 belongs to? Now, with the electronic configuration, you can actually predict the period, the block, and the group of elements in the periodic table without you having the periodic table. Now, the only thing you want to do is to know how to write the electronic configuration. And I've done a complete video on writing electronic configuration, and also using that electronic configuration to predict the group, the period, and block of elements in the periodic table. Now, a complete video will be linked at the description below, so you can check out that. But now let's do this one here. Now, once you see this, once I've been giving the atomic number, so the first one to do is to write out the electronic configuration. Now, for the sake of this question here, we are going to use the old electronic configuration, which is 2882. Now, majority of the questions you're going to see in your exam are going to be for the first 20 elements for hydrogen to calcium. So now, when the question like this be asked, now what you want to do here is use the old electronic configuration. So now let's say the element is X with atomic number of 16, right? So we are using 2882. Now, what does it mean? This one means first shell, second shell, third shell, and fourth shell. That is the meaning. Now, for the sake of this question here, we are using this system. Now, first shell means is going to get 2 electrons. Second shell means that you're going to get is going to get 8 electrons. Fourth shell is going to get 8 electrons. Then the third shell is going to get 8 electrons. While the fourth shell is going to get 2 electrons. So this will only work in the first 20 elements. As you move higher, this one never work again. You get. So you can use this sort of to get only the group. Now, what about the group of elements in the periodic table? The group of elements in the periodic table is also the valence electron or the outermost electron. Do you understand? So when you have been asked, what is group of the element in the periodic table? Do you understand? Now what you want to understand here is that you need to get the valence electron or the outermost electron, and the outermost electron is what that actually comes last. So here we have 16. Now, if you want to use this one to write the electronic configuration here, so here there is 2. So the first shell will take 2, right? The first shell will take 2. Now, then say the first shell have taken 2, and will be left. Here I have 18. Here I have 14, right? The second shell will take 8. So I still have 8 here. So 2 plus 8 is 10. That is, out of the 16 electron, I've used 10 electron, right? How many will be left? 6. So the third shell will take The third shell will take 6. So here we have 6. Normally it's supposed to be 8, but the number of electrons I have left is is 6. So I can easily use one here to predict what the group of the group it belongs to. Right there. Now in the periodic table here we have the group 1, the group 2, the group 3, the group 4, the group 5 to the group 8. Right there. So you need to study the periodic table for you to understand that stuff here. You understand? So yeah, my outermost electron, that is the electron that comes last, is what is 6. Now being as 6 is what is my outermost electron. So my outermost electron here is what is 6. So what does that tell you? Remember that the outermost electron, you also know what group number, right? Yes, also know what the group it belongs to. It means that this guy actually belongs to what, group 6 in the periodic table. That is the meaning. Group what? 6 in the what? In the periodic what? Table. So now let's go here. But you're using what Roman figure to denote it. You're using what Roman what figure. So you have 6, 1, 2, and what, and 4, right? So it means that it belongs to group 6. The answer is what is group what? 6. Group what? 6. Do you understand? Now, as they say the element is what is let's say Y14. Which period does it now? Which group does it belongs to? Which group does it belongs to? Now we have to use what 2, 8, right? 2, 8, making 10. Now how many electrons will be left? How many electrons will be left? 4. So it's going to be what? 4. This is what you want my outermost electron. Do you understand? My outermost electron, you also know what valence electron, you also know what group number, the group is what it belongs to. Now, if an element is what is about atomic number of what 14, that is the group number. The group number is what that the group it belongs to is what is 4. Is 4. Do you understand? So it's going to be like this. 4. Group what? 4. So if it's 13, it's going to be what group 13. For example, here we have if it's 13, like here we have Y13. So it's going to be what 283, right? This is what outermost electron, which is called the valence share, and the valence share is what is the group number. If now this guy actually belongs to group what 3. Do you understand? Now, if I have something like this, let's say an element Y is having what 11 as the as what atomic what number. Which group is it going to belong to? So it's going to be what 281, right? 281. Why? Because the atomic number is what is 11. So the first share will take what 2, the second share will take 8, the third share will take 1. So this is what my valence share, which also now with outermost electron, and the outermost electron just now what group number. So these are going to be what group what 8. That this element belongs to what group 8. Do you understand? Now, but now let me say this here. This one is called old electrical configuration. You can only use this kind this system when is what first 20 elements, and when they are talking about the group or the valence electron. Other than that, you cannot use this system again. So this one actually will suit these questions we are asked, right? So yeah, my answer is A for 16, 286 belongs to what group what 6, right? So let me move to the next question. Let me move to the next question. An element which has atomic number 13 is likely to have a combining power of dash. Just now, what you want to understand here is that combining power is the ability of it is the electron in which atoms use in bond formation. Now, when atoms want to form bond, they either lose electron or gain electron or share what electron. Do you understand? So it depends on the atom that they form bonds. So now the valency or the combining power is it's usually the outermost electron. Usually the outermost electron. So it is the outermost electron, atom or element we use to form bonds. And the formation of bond includes what? Can either be giving out of the electron or gaining of the electron or sharing of the electron. So the amount of electron in which an atom will give or gain or share in order to obtain the octet electron or stable configuration or stable electron is known as what the combining power. Do you understand? So if you should look at the element 13 here, right? So you favor what is the valence electron? It is the valence electron will determine will determine the combining power. Do you get that? So the valence electron, like what I've done here, you have 13 is going to be what 283, right? The valence electron is the combining power. It means that this guy have to give out 3 electrons in order to obtain the octet. Do you understand? So this guy will lose 3 electrons because it's a metal, it's aluminium. So the combining power of this element here, of the elements that have atomic number of 13, is what? Is 3. Why? Because of the atomos electron. Do you understand? Because of the atomos electron. If, for example, here I have 8 oxygen. What is, look at something here. What is the combining power here? Please pay close attention here. What is the combining power? Now, if you should look at, if you check very well. Now, if you check very well. Now, what is combining power? If you check very well, here we have 8, 2, 6, right? 2 what? 6. Now, this guy can't lose 6 electrons. So in order for this guy to obtain octet, he needs 2 electrons. Do you understand? So now the numbers of electrons in which an atom will lose or gain in order to obtain the octet is not what they are combining power. It's not what they are combining power. So the combining power of this guy is not 6, is what? Is 8, is 2. Do you understand? This guy is going to be 2. Why? Because he needs 2 electrons to obtain the octet electron. So if you see the combining power of oxygen is what? Is 8, right? Right? Oxygen is 8. So it's going to be 2, 6, right? That is, this guy needs 2 electrons to obtain the octets. Do you understand? But for 13, if I have something like 13, 2, 8, 3. Now, for the guy to obtain the octet, he needs to give out to this atomos electron. Do you understand? So now, metals in chemistry, metals gain electron. No, metals lose electron. Why no metals gain electron? That is what they are combining power. So the numbers of electrons in which an atom will lose or gain in order to obtain the octet configuration is what they are combining power. So for this one here, the answer is what? Is D, which is 3. So let's move to question 3. What is the maximum numbers of electrons in the 2s subshell? Now 2s subshell. Now the key thing here you want to look at is the 2p. Now they say that what is the maximum numbers of electrons in the 2p subshell? Now in quantum number we have called s, p, d, f. Do you understand? We have 4 orbitals, which are x, p, d, f, right? Now the maximum number of electrons in x is 2 electrons. 2 electrons. Then the maximum numbers of electrons in 6 orbital is is in p orbital is 6 electrons. Now the maximum number for d is 10 electrons. 10 electrons. Y for f is is 14 14 electrons. Are you there? Now, as long as we have seen p, the maximum, what is the maximum numbers of electrons in the 2p? P. 1 cp is what? 1 cp is what? Is 6 electrons. So the answer here is what? Is 6 electron. Very important. Now, if they say for x is going to be 2, d is going to be 10, and f is going to be 14. Do you understand? So that is for this one here. Now let's move to question number 4. How many electrons will oxygen need to gain in order to attain the stable state? So how many electrons does it need to gain in order to obtain the stable state? Now, if you look at oxygen, which I've already talked about before, but let me explain again. I will just wipe it because we have already answered this question. This question out here. So let me wipe this place. Now, oxygen, you are still going to use the old electronic configuration. All oxygen, the oxygen, the atomic number is 8, which was 2, 6. Right there. That is 2 electrons in the first shell, 6 electrons in the second shell, right? Now, octets. Now, when we talk about stable state, means what? The octet electron. And octet electron means what? 8 electrons in the atomos shell, right? Now, here is already 6. So how many electrons does it need to gain in order to get 8? Is 2. Do you understand? Is what? Is 2. Now, as when you have fluorine is what? Is 9, which is what? 2, 7. How many electrons does fluorine need in order to obtain the octets? It's going to be 1 because here is already 7. Do you understand? Now, if I have something like this, fluorine, fluorine is what is 17, right? Now, if I should write the electrical configuration here, 287. Now, how many electrons does chlorine need to gain in order to what to obtain the octet? Is what is 1. Do you understand? So the number of electrons each an atom gain or loss in order to what to obtain the octet is not what they're combining what power. Now, this now when the atoms or elements that would gain electron are what no metal, they're called what no metal. Why those that lose are called what metal? So yeah, the answer is what is 2. A is what answer. So let's look at what question 5. How many electrons are in the earth shell of uh P3115? Good. So this is where I want to explain how to write electronic what configuration. Now, in writing electronic configuration, you need the system here: 1x2, 2x, 1x, 2x, 2p, 2p, 3x, 3p, 4x. So please go and master this one here, because these are stuff you're going to see: 1x, 2x, 2p, 3x, 3p, 4x. Now, when I write, now most of the questions you're going to see when it comes to writing electrical configuration is going to be what this one here. Now, first shell, second shell, third shell. Do you understand? First shell, second shell, and what? Third shell. Yes, third shell, and what? Fourth what? Shell. Very important. So you have to what master this one here. Now remember you have X is what 2 electrons, right? X is what 2 what electrons. P is what 6 what electrons. Now, yes. So these are the two you are going to make use of. Now, D is what is 10, F is what is 14, right? Now, if you look at the question very well, they say L shell. Now, remember, in chemistry, we call K, L, M, N, O, P, Q, right? So, here we have this stuff here. K, L, M, N, O, P, Q, right? If you check very well. Now, K means what the first shell. L means what the second shell. M means what the third shell. N means what fourth shell. O means what fifth shell. P means what sixth shell. Q means what seventh shell. Do you understand? And this one means what the principal quantity number. So look at something here. Let me explain something to you so you will understand this better here. Now, when I see this one here, this number you're seeing here means what the principal quantity number, which also means what the shell. So first shell, which will only have 1x. Second shell, which have what 2x, which have x and what p. Third shell means what we have what x and p. Fourth shell have what x. Do you see that? So now this first shell here you have seen here is what is my k. Is what my k. Now this 2 here you are seeing here is what is my L shell. Now this 3 here you are seeing here is what is my M, right? This 4 here you are seeing here is what is my N. So you have to master this one here: 1x, 2x, 2p, 3s, 3p, 4 x. My 1 is what is my k shell. 2x, 2p, they are what in what L shell. 3x, 3p are what M shell. 4x is what N shell. Do you understand? So you have to master this one here. Now, how many electrons are in the what L shell? You have to write the electronic what configuration. Now, P, the atomic number is what is 15, right? Now let's write the electric configuration of what of 15. So let's take the first one here. Now, when 3 electrons, now you must start from what for the lowest to the what to the highest. Do you understand? So now let's take the first one here, 1x. Now x will accumulate how many electrons? 2 electrons. So here we become what 2. Because for you to what solve this question, you must write the electronic configuration very well. You must do what? You must write the electronic configuration using what this system of what writing electronic what configuration. So here we have 1x. Now remember, x will accumulate how many electrons? 2 what electrons? 2 electrons. So here we have 1x2. Now let's move to the now that is my k shell only have 2 electrons. That is me. because here we have K shell. That is the number of electron here is what is in what K shell. Now let me take the other one here. 2x. Now remember, x we what take 2 electron 2, right? So you have 2. Then here we move to what 2p. P we take how many electron? P we take how many electron? 6 electron. Put 6 here. Now let's calculate total numbers of electron we have used. Now here we have 2 plus 2 plus 4 is what? Plus 6 is what? Is 10. So out of the 15 electron, I've used 10. Do you understand? So I still have more 5 left. So now let's move on. Let's move to the next one. Here we have 3x, right? 3x. 2 will be here. So we now go to make it what 12. Then here we now 3p, making what 3 here. So if you check it very well, 2 plus 2 plus 6 plus 2 plus 3 is what? Is 15. So I have exhausted all my electrons. So this is what electronic what configuration of what phosphorus. Now I've done a complete video step by step, focusing on only what writing electric configuration. If you're interested to watch that video, I will leave the link at the description below. So this is just like a revision class, show you how questions have been set and how to tackle those questions. You get. But if you want to watch a complete video of all these questions and this topic here, most of this topic here have been created, so you can go to the description below and you see most of those questions. Or if there's any topic you want to learn, you just ask it on the word comment section. If I've already created the video, I will send you the link to those videos. But if not, because of you, I'm going to create videos on that, so that your stress will ease for you, so that you can cover this topic fast and better, and so I can have time to read other subjects. So now I have a result of my electron. Now they're asking, let's know what they ask again. They say, how many electrons are in the L shell? My L shell means what? Second energy level. I have 2 and 2, right? How many electrons do I have in this 2x? Is 2. How many electrons do I have in this 2? In this is what? In this 2p is what? Is 6. Added together, you have 2 plus 6 is what? Is 8. Is what? Is 8. So the question, the answer here is what? Is 8. Is 8. Do you understand? Now, as we will be asked, how many electrons are in the M shell? How many electrons are in the what? M shell? Because here is what? K. My K shell, the numbers of electrons is what? In the K shell is what? Is 2. Right? So here, L equals to what? 2. My okay, K is what? Is 2. My L is what? Is 8, right? L is what? 8. Then M. My M here is what? Which is what? My M. What be my M? My M is what? Is 3, right? 3. So going to be 2 plus 3. M, which is going to be what? 5. Very important. You find that all these options and all these values here are in the options. Here we have 2. Here we have 5. Here we have 8. Here we have what? Here we have what? 18. So if you don't really understand this thing very well, you will not be able to what? You will not be able to get the right answer. So they say what? K share. They say what? L share, and this is what my L share. 2x 2p. So what I will just is to add it together. Do you understand? But as when I say my M share is what? Is 3. I will add 2 plus 3, giving what? 5. But they say what? L share. So that's why the answer is what? Is this number 8? Is this what? Is 8? Yes, C. Right? So let's move to what the next question here. They say that if the electric configuration of an element is 1x2, 2x2, 2p6, how many unpaired electrons are there? So this way I'm going to explain stuff for you again. Let me explain stuff here. So how do you know numbers of paired and numbers of unpaired electron in what? In a suborbital. Now look at something here. This is what you need to understand enough to be able to solve this problem here. Now X have what? 1 suborbital. You have to understand this here. P have 3 suborbital. P have what? 3 suborbital. D have what? 5. No, yeah, 5 suborbital. 1, 2, 3, 4, 5. Right there. Then F have what? F have 7. 1, 2, 3, 4, 5, 6, 7. Do you understand? Now, Remember, when filling now, according to On's rule state that when filling electrons into degenerate orbitals, electron will first spin up before spinning down. You have to understand this here. Now, if you look at this one here, they say, no, this should be 5. This is 5, not 6. 5. Mega correction. Yes, 5. Now, here we have 1x2, 2x2, 2p5. Now, you're going to target the last one here. Just like you're going to target the last one, which is what? 2p5. Right there. Now, p have suborbital, 3 suborbital. So you have to write this here like this. 3 suborbital, right? Now, for us to get the numbers of unpaired, now, how many electrons do we have here? 5 electrons, right? Now, when you arrange the electrons in this orbital here, now you must therefore fill it singly. So that is, they must spin up 1, 2, 3, right? Now, the one that is left now, they must spin up before they will spin down. So 1, 2, 3. They now come back again to spin down. 4, 5. Do you understand? So from here now, you now know what mass of paired and what mass of unpaired. Now those ones that have it up and down, they are all paired. So this one is paired electron, paired electron. Those are called unpaired electron because there's no electron to pair down. So the numbers of unpaired electron here is what? Is 1. The numbers of paired electrons here is what? Is 2. Now the question they ask, they say, how many unpaired electrons are there? We only have 1 unpaired electron. So the option is what? Is A. Option what? A. Now let me explain this to you again. Imagine you have 3p4. Now how many electrons, how many unpaired electrons am I going to have here? How many unpaired electrons am I going to have here? Now imagine you have 3p4 as the last one because you pick the last one here, right? Imagine you have electric configuration and the last one is like this. How many unpaired electrons is it going to be or is it going to have? Now P, right? If you look at P here, now here we now have 4 electrons, right? So 3 first spin up before 1 come and spin down, right? There we have just all our electrons. So you will have 1, 2, 3, 4, right? So how many unpaired electrons do I have here? How many unpaired electrons do I have here? How many unpaired electrons do I have here? Here we have 1 paired and 2 unpaired. So here we have 2 unpaired electrons. So if I have something like this, please pay close attention here. Maybe I have 4d8. 4d8. Now let's say if they should ask you here, how many unpaired electrons do I have in this one here? Now remember, D is having suborbital 5. 1, 2, 3, 4, 5, right? So it will be like this. 1, 2, 3, 4, 5, right? How many electrons am I have here? 8. So therefore 5 is spin up. So you have 1, 2, 3, 4, 5, right? Now out of the 8, I've used 5. How many left? 3. So you have 5, 6, 7, 8, right? So how many unpaired electrons do I have here? Here I have 3 pairs, our 2 unpaired. So you have 2 unpaired electron. So the answer is this one here. That is it. Do you understand? So please, if this video is helpful, please leave a comment section that this video is helpful. Please, if you're not subscribed to the channel, please hit the subscribe button so that you get notification whenever new videos be uploaded, because I upload videos on a constant basis because your exam is very, very close, so that it's going to help you. I upload video on math, chemistry, and physics, so it seems to be more easier for you. So kindly share this video with your friends who also look for this type of content, because when exams get close, so many students will be so anxious, like so many of us are on the rest, and they want to try as much as possible to cover so many topics. So that is the reason why we are creating this content, to help as much as possible people we can get to. So you can help reach to other persons here. So if you are watching this video, I have your group of friends who are also write chemistry, please, and you know that this video is going to help them, please copy this link and send to them. It's going to be of help to them. At the same time, you also promoted this channel too, and we'll get you more subscribers. Okay, how many principal electron share as an atom whose electron configuration is this? So they ask you how many principal quantum number, do you have there, or principal share? Do you understand? Again, back to that K, L, M, N, O, P, Q, right? So Here we have 1, 2, and 3. Just 3. The answer is 3. So the answer of the principal share, right? So we have the first share, second share, and third share. KLM. So here we have KLM. So just 3 of them. So the principal share is what? Is 3. This is what answer here, right? So let's move to question 8. Element S has the electric configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Each atomic number and group number in the periodic table will respectively by or be. So it's supposed to be will respectively be yes. Now let me explain this for you very well. Let me explain this one very well for you. Now here we have 1x2, 1x2, 2x2, 2p6, 3x2, 3p6, 4x2. Are you there? Now, therefore they say that the atomic number. So what is the atomic number? To get the atomic number, add everything here. This. 2 plus 2 plus 6 plus 2 plus 6 plus 2. I'm going to give you what? 20. Do you understand? So the atomic number is what? Is 20. It's okay. The atomic number is what? Is 20. Yes, it's 20. Now, how do you get the group? Remember that the group is what? Is the electron in the what? Highest energy what level, or the outermost electron, right? Now, if you look at we have 3 principal quantum share, right? Here we have 1, 2, 3, and what? 4. So 4 is what is the highest. So how many electrons do I have here? How many electrons do I have here? How many electrons do I have here? Please understand here. How many electrons do I have here? Here we have 2. So that is this thing have this element here have 2 outermost electron or valence electron, and the outermost electron or valence electron is also about group what number. It means that this guy belongs to group 2. So the group it belongs to group what? So you use what Roman figure here, group 2. So it's going to be 20 and 2. Let's check the correct option. 20 and 2. So this is what correct option here. B is what is correct option. Do you understand? B is what is the correct option. Now, let me explain something to you again. Let me explain something to you here. Now, imagine we don't have 4x2 here. Imagine we don't have 4x2 here. Listen to me carefully. Imagine we don't have 4x2. We only have 1x2, 2s2, 2p6, 3s2, 3p6. Now, imagine we have this here. Now, what is my atomic number? Atomic number. My atomic number is very easy. Sum all this electron here. 2 plus 2 plus 6 plus 2 plus 6 is what? Is 18. 18 is okay. Now, how do we get the group or the valence electron? Do you get that? How do we get the valence electron or group? So the group here is very easy. Please pay close attention here. Now, here we have 1, 2. Here we have first share, second share, third share. Third share is what? Is the highest energy level. Right there. Now, when we did something like 4x2, it was only what? 4, right? So we just pick this guy. Now, but for the sake of this guy here, please pay close attention. For the sake of this guy, 3s2, 3p6. Now we have 3x, 3p. So you cannot just pick the last one here. Now we have 3s, 3p. So what I want to do here, we want to sum 2 of them. 2 plus 6 is going to give me what? 8, right? 8. So then this guy belongs to what? Group 8. That is me. It belongs to what? Group 8. Please pay close attention here. So if you look at the last principal quantum number here we have 3x, 3p, right? Now because they are the same energy level here, you add the electrons together. Do you understand? So if you have this guy belongs to what? Group what? 8. So the group is what? The group what? 8. Very important. And if you check it very well, this element is argon. Argon belongs to what? Group 8. The octet, the group, yeah. The noble gases, yes. The noble what? Gases, yes. That is it. So we are done with this one here. Let's have question number 9. In the aluminum ion, look at the aluminum ion. The mass and the electron number are respectively. So what is the mass number and the what electron number here? So let's look at it very well. So here we have Al3 plus, here we have what? 27, and here we have what? 13. It's okay. Now, just like when we have A, B, A, Z. A is what? Mass number. Mass what? Number. Z is what? Atomic what? Number. Or what? Proton what? Proton what? Number. Or proton number. Very important. Yeah. So automatically my mass number here is already what? 27, right? Now, how do I get my electron number? Look at something here. In a neutral atom, now, what do you say by neutral atom? In a neutral atom means that it does not have any charges. For example, here we have aluminium here, Al 27 and what 13. This is a neutral atom. In a neutral atom, the proton number and the electron number are the same. Just the proton number and the electron number are the same. As we are looking at this one here, that is my electron number here would have be electron number here would have be what? 13. It's okay. Electron number here would have be what? 13. But here is current charge here. Now this is where you need to understand here. Now whenever you have a positive charge here, it means that it has what? Lost electron. And whenever you have a negative charge here, it means that what? It have gained electron. You get. Now this plus 3 here means that it have what? Gained, it have what? Lost 3 electron. That is meaning. So my electron number here is not going to be 13 again. It's not going to be 13 minus 3. It's going to be what? 10. Do you understand? 13 minus 3. So this one will be the opposite. So that will be 13 minus 3. It's going to be what? 10. So what is the correct option? Let's check if the correct option is here. So it's going to be what? D. 27 and what? And 10. This is what correct option. So you can see our questions are being set under what? Atomic structure and what? And bonding. Now these are the first set of questions I'm doing here. More questions like this, more videos like we will release what math, chemistry, and physics. That is why if you're not subscribed to the channel, please enable you subscribe to the channel and turn on the notification bell icon so that you can get every single thing we will be uploading on this channel, right? Like what I said, please try as much as possible to share this video to other of your colleagues writing JAMB. If you have any sibling, please try to share them. So like what I said, I've done a complete video on organic chemistry and the calculation aspect of the chemistry. So you see the video at the end screen.